Okay, I'm going to add another level of complication to this, sampling with or without replacement. When I pulled my first red Lego out of the cup, was anyone wondering, is she going to put it back? It's a really important question, because if I don't put it back, my chances of choosing the red the second time has changed. And if I think about when I had a purple one in there, if I choose a purple one the second time, there's no way I can pull a purple one out. Sorry, if I pull a purple one out the first time, there's no way I can pull a purple one out the second time. So it matters, did you put it back? And we call this sampling with or without replacement. The sampling bit is when I choose one. I just took a sample, okay? I replaced it. I took a sample, I replaced it. That is sampling with replacement. And now I'm going to choose two without replacing. I got a white one the first time. I got a red one the second time. This is sampling without replacement because I didn't put them back. All right. So the question is, did you put it back? If you did, that's sampling with replacement. I replaced the first one back. If I didn't put it back, that's sampling without replacement. Now, what I've just shown you before is sampling with replacement. You saw me putting my little things back each time. How do we do it when it's sampling without replacement? This is where tree diagrams are really, really useful. So this is what my tree diagram is going to look like. I'm going to do a two-step experiment, choosing from this cup without replacement. My first branches of the tree will be the same. I can either go red or I can go white, okay? Chances of red, 3 out of 5. Chances of white, 2 out of 5. All right, now we have to think, what would happen if I take a red one the first time? Now I've got 2 red and 2 white left in my cup. So if I took a red one the first time, what's the chance of pulling out a red one the second time? It's 2 out of 4, which we can simplify to be a half. Well, if I choose red the first time, what's the probability that white will come out the second time? Also 2 out of 4, which I will simplify to be 1/2. Okay, what if I didn't choose red the first time? What if I got a white one the first time? I got a white one the first time. What's the chances now of pulling out a red one? It's 3 out of 4. What's the chances now of pulling out a white one? 1 out of 4. So I want you to notice a couple of things. My denominator has decreased each time from the first step to the second step. Not my simplified denominator, but the denominator before I simplified. And similarly, if I had simplified this, if there were actually 10 in there, then it would be the original number that subtracted. And then because I pulled out red the first time, my numerator also decreased by 1 for red, but white didn't change at all. White 2, white 2. Right? Going down here, I pulled out white the first time, so my white numerator has decreased by 1, but the red has not changed from the original number in the numerator. The denominators have decreased by 1. Okay, so my question is, what's the probability of getting white then red? So I start, having done nothing, I pull out a white Lego, then I pull out a red Lego. My probability is going to be 2/5 times 3/4. Now I can simplify this. 2 and 4, 2 goes once, 2 into 4 goes twice. So I end up with 3/10. The probability of getting white, then red, is 3/10. All right, let's sum up. So we're looking at two-step experiments, and the first thing we need to know is how can we find the sample space? We either use an array or a grid, or we use a tree diagram, and that will give us a list of everything that might happen. To calculate probability, I'm going to put on my numerator the number of ways that my event can happen. That's NA, where A is my event. And on the denominator, the total number of things that can happen. That's the number of things in the sample space. If my outcomes are not equally likely, I'm definitely going to use a tree diagram. I have to pay attention to whether I've got sampling with or without replacement, and I'm going to multiply my probabilities. So probability of A and then B is the probability of A happening multiplied by the probability of B happening, but remembering that the probability of B might look different if it's sampling without replacement.